Hello everyone, my name is Barbara and I would like to welcome you all to our latest Novedge Webinar episode. This week, Solid Edge, Design Without Boundaries in a Multi-CAD World. Solid Edge with Synchronous Technology offers design engineers a new groundbreaking way to design faster with more flexibility. Whether your design consists of brand new parts modeled from scratch or existing parts modeled in other CAD systems, Solid Edge allows you to get your products to market faster. Presenting the webinar today is Kevin Grayson. Let's see if, okay. Here's Kevin. Kevin is an application engineer in the Siemens Channel Enablement group with more than 14 years of experience with Solid Edge. Kevin has also worked as a Solid Edge certified instructor and has trained hundreds of Solid Edge customers. Before we get going, here's an overview of what we do in Novedge. Novedge is one of the largest online stores for design software. We offer a huge assortment of software solutions that cater to virtually every designer's need. Put us to the test and come visit our webpage at novedge.com, and please take advantage of the special buy one, get one for free Solid Edge promotion. This promotion don't happen every season, so this is very special. Check it out. For more daily software news and limited time promotions, pay a visit to the Novedge blog and follow us on Facebook, Google+, and Twitter. Coming up next week, a look at Arconivo, next generation architectural visualization software from Elecosoft. Arconivo is a powerful standalone 2D and 3D CAD program for all types of building design. Last but not least, today's webinar is free and is being recorded. So if you want to rewatch this or any webinar on our collection, just head on over to Novedge's YouTube or Vimeo channel. And now, finally, I'll be able to pass the screen to Dan first, so we can start the presentation. Enjoy. We should be able to see Dan's screen. Here you go.
Thank you, Barbara.
Hi, Dan. You have to make it full screen. Perfect. Take it away.
Okay. All right. Thank you very much. And thank you for joining us, everybody. Hope everybody's having a great day so far. Good morning to those of you on the West Coast. Good afternoon to those of you that are out east with me. So my name is Dan Monette. I work for Siemens Product Lifecycle Management on the Solid Edge team. Thanks for sharing this opportunity. Thanks for Novedge for giving us this opportunity to share information about Solid Edge. What we really want to talk about, Kevin and myself today, is a problem with which you'll see in a moment is a common problem in design, and that is the problem of importing CAD geometry. Whether it's from your customers, your clients, your other departments, not everybody uses the same CAD tool, and this poses challenges. So I'm going to set the stage, just a little bit of information before we turn it over to Kevin, who's really going to give you the exciting part of the presentation today, actually a live demonstration of Solid Edge. So we're going to talk about importing geometry, the basics. Many of you on the call probably do this all the time. Probably going to tell you some things that you already know. And then we're going to jump into a demonstration of what we call next generation CAD, synchronous technology that's found inside of Solid Edge. In 2013, there was a study done by Lifecycle Insights and Longview Advisors studying the reuse of CAD. And here's the long title of the document, and you can find this on the internet still today. 2013 State of 3D Collaboration and Interoperability Market Report. It's a rather exhaustive report that looks into, among other things, the reuse of data, data exchange, importing CAD files from dissimilar systems. And I believe it was about 840 respondents in this survey that was done. And you can see here that the number of design data files exchanged on average per month is pretty startling. Many of you need to import geometry that was created in a different CAD system on a daily basis. Number of hours then that some of you are spending on fixing that design data, because as you know, it doesn't always work as planned. Maybe the features come in, maybe they don't come in. You spend some time fixing that design data. And again, there's a significant, more than a third of you are spending a significant number of hours per week fixing this imported data. We think we have a solution for you to improve that situation. Modification of imported geometry the traditional way. You know, most of the CAD systems that are out there on the market today use the traditional import method, and the implications for your company and for yourself can be negative, to say the least. Time spent repairing is non-value added. That's not really helping you design. High volume of design data exchanges are a time waster. This is time that we think we can get back for you with synchronous technology in Solid Edge. This is the question you ultimately come to after spending hours, perhaps, trying to get your customer's file inside your CAD system. Is it faster to just fix it, continue trying to fix it, or just rebuild it from scratch? That's all wasted time. So traditional CAD really poorly supports the modification and manipulation of imported design data. We want to talk to you about next generation CAD, which we believe, and we're going to prove to you, fully supports the modification and manipulation of imported design data, imported from dissimilar CAD systems. Some of the implications, instead of the negative implications for your organization and yourself, are going to be more positive. Less time spent fixing errors, increased productivity, fewer or no missed deadlines, increased customer satisfaction, increased job satisfaction for us engineers. So the next generation CAD that we're talking about is Solid Edge with synchronous technology. Synchronous technology is unique in the industry, and it's really the magic sauce that we're going to show you how to get around all of these imported CAD file issues with. So with that, let's jump to the exciting part of the presentation. It's going to turn it over to Kevin for a demonstration of next generation CAD technology.
Thank you, Dan. And you should be able to see Kevin's screen very soon. Here you go.
All right. Can everybody see my screen okay?
Looks great, Kevin.
Looks good.
All right, great. Thank you. Well, thank you, Dan, for the introduction, and thank you, everybody, for joining us on the webinar today. I'm going to go into some depth on what Dan focused on in the initial PowerPoint presentation, and I hope that what we show you today is going to be beneficial. Hopefully, some of the workflows and the tasks that we go through in the demonstration will be familiar to you, especially if you're one of those who does have to utilize CAD files, whether it's legacy data from your company or whether it's data that you may import from a customer or a supplier, and you need to manipulate that data. We're going to show you a number of tools inside of Solid Edge that's going to make that process much more efficient and allow you to get your products out there to market much faster. We're going to go through a scenario here. We're going to utilize this motorcycle. We're going to kind of go through a day in the life of maybe an engineer who's tasked to complete the design or work on an area of their particular project per se. And the first thing that I may want to do is just turn off some of those outer components. We'll kind of see the framing components, and as the engineer, I've been tasked to work on the back of the motorcycle. We have, you can see here, our shock. We need to bring in a mechanism that's going to connect our shock to our swing arm here in the back, as well as to the frame, so that as the bike's traveling down the road, it's going to connect those components together. And we're going to run through the scenario specifically where we have maybe some legacy data from another CAD system. We are an existing Solid Edge customer. We have some parts that were designed natively here inside of Solid Edge, but we've run into a situation where we want to bring in some components that were designed in our previous CAD system. And we'll go through a couple of different examples and showing you different file types that you may work with and how we can work with that data inside of Solid Edge. The first thing that I'm going to do is I'm going to go back to our legacy files. So as I go to that structure You'll see here that we have some files that we want to bring in. These are non-native SolidEdge, or I'm sorry, these are files that were designed in this particular example in SolidWorks. Now, it doesn't matter if the files are SolidWorks or maybe some of the other CAD packages that you may recognize here in this list. But the point that I want to make here is these file types can be opened directly inside of SolidEdge through your typical file open structure. So you'll see here the files that are towards the top are the native SolidEdge documents. As you work your way down the list, you'll see some other familiar file types from other CAD systems that we can read in directly and work with. As I mentioned, we're going to specifically, in this example, work with a SolidWorks assembly. So I just simply select that option, and I just open it up right into the SolidEdge environment. And here after a second or so, you'll see that that assembly comes right in to our window here. I'm going to go ahead and save that. And what I want to point out is with the SolidWorks assembly, it not only is going to bring across the assembly file itself, but it'll also bring across all the individual part files. So you'll notice the file structure here, all the different sub-assemblies, as well as the individual part files are located over here in what we call our Pathfinder structure. Now, if you are one of those designers or engineers who brings in non-native geometry from those other CAD systems, you know that typically when you bring in data, it doesn't come in with the native intelligence in which those parts or those assemblies were initially designed with. So in this example, assembly relationships or constraints, or if we're working specifically with a part, the sketches or the dimensions or the constraints that were placed in the individual sketches which make up the components. None of that information translates over as you open it up in another CAD system. But with SolidEdge, it doesn't matter because we have tools that allow us to work with this data very easily. Before I get started with working with the data, manipulating the data, just wanted to show you some tools here. Again, you'll notice the colors in the CAD system from which this data came from. Not the best. We may want to go ahead and just change the look of some of these components. So we have some nice tools here where I can select a component and then say, you know what, let's select all of the parts of the one that I selected if there are multiple, and I just want to change some of the colors, for example. We'll do the same thing here with the bearings. I want to select all of those components, and maybe we'll also select maybe the screw and the nut, and we'll change some of the display colors here. So maybe we'll change this maybe to a more chrome-like. And you can see SolidEdge has really nice textures to make these parts look very realistic. Now we can do this here at the assembly level. If we want to go specifically into the part level, we can do that as well. I may want to just double-click on that part, and we can easily change the look here as well. And why it's important to do this here from the part level is we can also get access to information. For example, if I change this to steel, we can see all of the property information, density information, and some of the other material characteristics, which will lend itself to weight calculations and some of those other properties. I'll do the same thing with this last component here. We'll maybe change that to steel as well and make the part look a little bit more realistic. So we'll come back out to the assembly, and obviously those parts look a lot better. The other thing I want to draw your attention to is we talked about the assembly structure coming across, so the sub-assemblies and the individual parts. One of the things that you'll notice too when you open up data from other CAD systems is those assembly constraints don't come across automatically. And that's true for any CAD system. If I were working in SolidWorks or Inventor today and I opened up a file from NX as an example, I don't get those assembly constraints. But what you'll notice is they just come in what we call a grounded state. So they are there relative to their original position, but there is no assembly intelligence. So what I want to do is I want to show you some tools that are built into SolidEdge that allow you to add that intelligence back into the assembly very quickly. The first thing that I want to do is I just want to get rid of those dumb grounded constraints. I'm going to tell SolidEdge, just go ahead and remove those. And what you'll notice is as I select on any of those parts, that grounded relationship is now gone, and I've done that for each of those components all at the same time. And what I may want to do now is utilize that same tool to add that intelligence in automatically and save myself from the manual process that the other CAD systems out there on the market have to do, where they have to individually constrain those components one by one. So the first thing that I'm going to do is, let's go ahead, for example, let's take maybe those bearings that reside inside of this housing, and we'll go ahead and constrain those automatically. So the first thing that I'll do is I'll just tell it to place those inside of the housing, and you'll notice that Solid Edge says, well, what types of relationships or constraints would you like to apply? And in this case, we'll just do some alignments, both axially and planar. And notice as soon as I click Process, Solid Edge almost instantaneously will find all of those assembly constraints for us. It'll find if there are any offsets. So in this case, the bearings are flush with the face of the housing, so I get a 0 offset. But if I wanted to apply an offset, I can do that. I can also pick and choose specifically which relationships it's going to apply automatically to that assembly. So as I select any of those relationships, it highlights specifically which ones it's referring to. I'm going to accept all of those. And then we'll do the same thing for, let's say, these components. I'll maybe grab the screw, the nut, and then this other component here. And we'll do something very similar. We'll run through this. This time I'm just going to say, let's look amongst the parts themselves. And this time maybe we'll add a couple of other assembly constraints, maybe some mating conditions, offset values. We'll process those, and again, instantaneously it finds mating conditions and alignments, and we'll accept all those as well. So you'll notice that as I select any of the components, maybe this component here, it'll automatically show me those constraints down here on the bottom left side, the mating conditions and such. Now I can also go through and just do some manual constraints just by selecting geometry. I can say let's align this to this, and it does it automatically for us. Or maybe I want to say I want to keep, for example, this component centered between these two faces, and I want to keep it centered in this part. And what that'll do is that'll keep that part from sliding back and forth along the screw there. So again, you'll see here as I select a component, I can very easily see any relationships that Solid Edge has automatically applied, and that just establishes that intelligence amongst the assembly. The other thing that you can do, just to show you if you wanted to go back and edit any of these, I can select any of those relationships. For example, that bearing is flush with the housing as we showed you before. If I typed in an offset value down here at the bottom, you'll see that it'll adjust. In this case, 5 millimeters, or if I wanted to push it in -5 millimeters, I now have full control over that position of those components. Or also, as an example, if I decided that I want to change which parts are constrained to which, you'll notice that I can select any of those relationships and modify those as well. So let's say, for example, for this screw, I'm going to take the alignment here to part 501, and I can say, let's maybe change how that part is constrained. Maybe I want to constrain it to this component. And now it switches from 501 to 502 in this case. So again, it allows you to add that intelligence back in very, very quickly, and allows you to establish those relationships. So this mechanism, as I mentioned, we're going to bring this into our motorcycle. This is what's going to connect our frame to our shock and to our swing arm. So let's go over to that motorcycle assembly, and let's just bring that in and constrain it. So we'll just go over here to our library. We've saved the file over here. It's located, and I just simply drag this into our top level assembly. And it's nice we can move these components around if we need to access specific geometry as we constrain. But in this case, I'm going to select the cylinder of our boss and just say let's align it to the screw. We'll do something similar to what we did earlier, where we want to keep that part centered. So we'll center these components relative to some of our supports on our frame, and we'll just easily select those. And it pushes that and centers it up. And then the last thing we'll do is we'll constrain the boss up here at the top to our shock. And you'll see those components will automatically constrain themselves. The last thing we may want to do as well is maybe constrain to our swing arm and get those positioned and lined up accordingly. Now, as we bring that in, we want to go ahead and test the validity of our mechanism. Let's see exactly how this is going to perform in reality. So obviously our shock here has a minimum and maximum stroke. We might want to test and make sure our parts aren't going to interfere and test for that right up front. What's nice about Solid Edge is we can recognize and adjust components based on how they would be simulated in real life. So as an example, I may want to take the shock, and you'll notice as I grab the components, those assembly relationships are going to follow suit. As I go to the minimum stroke of our shock, you know, everything appears to be okay. But notice as I go to the maximum, you'll notice we're running into some interference. And Solid Edge has some really nice interference detection tools, which we can go ahead and have parts highlight, and it'll show us that interference. But we can see that very obviously here, that these parts are interfering as that shock is extending out. So we know that we're going to have to make some adjustments to our design. Same thing here as we rotate around. We have some obvious interference connected to the swing arm here in the back as well. We may need to adjust some of these components so that we can eliminate that. So let's go back into that subassembly, and we'll make some of these changes. And we're going to do this in a couple of different ways. So typically in a traditional CAD tool, when you want to make changes to components, you will go into the specific component that you want to change. You'll make the modification, which then reflects up to the next level up. So for example, if I want to change this part, I'm going to change it in the part, and then it's going to reflect that change in the subassembly, and then that change will be reflected in the higher level. But the user is finding themselves having to dig down to find the components and make those changes at that level and then work their way back up. And we'll do that also in this particular example, and then we'll show you some other benefits that Solid Edge has that will eliminate that step. All right, so the first thing that we're going to do is I'm going to edit into this part. We know that we want to make some changes to it, and we can make those changes while viewing the rest of the parts, or we can turn those other parts off. So here's one of the other things that we had mentioned in terms of importing data. You'll notice here that I don't have any features, I don't have any sketches, I have no dimensions, I have no constraints, because this is an imported part. But I need to make changes to it. So in a traditional CAD tool, how do I do that? And this is where we go back to the question that Dan mentioned earlier. Is it faster to just redesign this part and make those changes? Or is it going to be faster to make some sort of modification to this part? Well, in the other CAD systems, I don't know the answer to that question. But in Solid Edge, it's going to be much faster to just quickly change those components. What you'll also notice is that some of the other CAD tools out there will claim that they have direct editing tools. But you're going to notice that those editing tools are very simplified and can't do very much. And I'm going to simulate what other CAD programs do. For example, if I need to change the spread distance between these two holes, what another CAD system out there on the market may do is say, well, I'm just going to move these faces, and they have very rudimentary move face commands. As an example, if I select the hole and say I want to move that hole, what it's going to do is it's just going to move what I've selected. So it doesn't know to move the boss at the same time. It doesn't know to move the tangent rib structure. So in those other CAD tools, we may have to come out and say, well, I want to move that, and I want to move that. And we'll do that again with that simplified move face tool. And I may say, let's move that face and that face. Again, we want to move it in a specific direction. And you'll notice again, it's not doing exactly what I want it to do. It's kind of moving the boss, but again, it's not moving the faces tangent to that boss. And as we get to a certain point, we may run into some errors. And again, this is what you'll see in a traditional CAD tool. Same thing if I decided, well, let's go ahead and maybe select all of these faces. And again, this is selecting these one by one. We can select them, but are we going to get the result that we're looking for? Let's try. And again, we're still not getting the result that we're looking for because there's no intelligence built in. Well, in Solid Edge, that's not the case. So let's go back into showing you what Solid Edge has built into the tool, and this is what we call Synchronous Technology. What you'll notice is that as I select the hole itself, Solid Edge comes up with a nice design intent window, and it's telling me right out of the gate what it automatically recognizes with my part. So it tells me, hey, I recognize that this part is symmetric. I recognize that there's a boss that's concentric with that, and I also recognize some other things. So how's this going to work? As I select that hole and make some adjustments to this, notice how it's also moving the symmetric hole automatically. It's also moving the tangent faces as well. So I can very quickly, if I wanted to change the spread distance, adjust that spread distance just by simply moving that hole. Or what most designers or engineers are typically used to using are intelligent constraints or dimensions. I know as an engineer myself, I'm used to working with precise dimensions because I want to make a precise change to this part. What's nice about Solid Edge is I can directly place dimensions on the 3D geometry. I don't have to work with 2D sketches. So for example, if I want to place a dimension between those two holes, and I'll just place some other dimensions out here as well to locate some other features, I can place those dimensions very quickly so that I can make changes very quickly. So here, let's say, for example, I'm going to make some changes to this dimension. You'll notice that as I select the dimension and start making changes, and again, I'm using my scroll wheel to do this just to show incremental changes, notice how I can change the dimension directly, which modifies the model right out of the gate. The other thing, too, with traditional CAD systems is typically they're used to working with 2D sketches, and let's just imagine that we're working in a flat 2D sketch. If I want, for example, these two faces to remain, or these two lines, I should say, to remain parallel, I would come to my 2D constraints and apply that, and then it would remain parallel. In Solid Edge, we can again apply constraints directly to the 3D model. For example, if I want these rib thicknesses here to remain that specific value, I can apply these relationships automatically as well as apply a specific dimension, in this case 4 millimeters. And we'll do the same thing down here. So again, I don't have to go into any 2D sketches. I don't have to redraw or rebuild any 2D sketches. I'm working directly with the solid model. So again, let's make that change now to the dimension. And you'll notice that Solid Edge is going to maintain the symmetry because the part as it was brought in was symmetric. But what if my design team wants to make some changes to where now we don't want a symmetric part? Well, what's nice about this is I can tell Solid Edge, let's go ahead and turn off the symmetry. I just simply uncheck that box, and then I can come in and change this part as I want. So you'll notice now I can move just the top hole and make that modification without affecting the bottom hole. And I can do that same thing. Let's say maybe I want to move this hole to a certain value. I can go ahead and modify that, and we'll do the same thing. Maybe we want to move it down to another value. So just by simply changing those dimensions, we have very quickly changed the design of our part. And then just to just finish this out, let's go ahead and maybe round some of those sharp edges. I'll just window select around the entire part. We'll get rid of these sharp corners and apply some nice fillets there automatically to that part. And then maybe we'll put a chamfer on these inside faces. Again, I just simply select those and we'll put that chamfer on there. And now we've made the specific design changes. But again, you'll notice how easy it was to do that. So we'll go ahead and come back out to the assembly. Now what you'll notice as well is, remember, in the previous step, we had applied intelligent assembly constraints. So as I modify this part, Solid Edge knows to automatically move those bearings and keep those bearings aligned with our bosses because of those intelligent assembly constraints that were added. Again, we'll save that. And those changes, as you'll notice as I come back out to the top level of the motorcycle, those changes are now reflected in our top level motorcycle. So let's go back. So again, just to reiterate, In that example, we went down into the part model, made those changes, which then were then reflected up to the subassembly level and then reflected obviously in the top level. But Solid Edge doesn't have to make changes at the part level only. If we want to make other types of changes to our components, we can do that at the assembly level. And just to show this, I'm going to open up this component for a second. And again, just like the other component that we just worked on, again, this is an imported part. There's no features, no sketches, no constraints, no dimensions. It's just a simple body feature. But what if I want to add some intelligence back into this particular part? So just to show you some of the tools that are available, one thing that I can do right here from the assembly without going into the part is I may want to recognize the holes. So I simply say recognize the holes in this particular model. Solid Edge will say, hey, this is a counterboard hole. If I decide I want to change what type of hole it is, maybe it's maybe a simple hole or a counterboard hole or a threaded hole, I can go ahead and change the hole type or change any of the parameters. I can also specify, what standard I'm utilizing. But maybe I want to change it from a counterboard hole maybe to a nice simple through hole. So I simply select OK. And right here at the assembly level, I have now modified that part and changed its parameters. We can do the same thing with chamfers as an example. Maybe I want to recognize the chamfers in this part. Very similarly, it says, hey, I've recognized you got two different chamfers, and maybe I want to, for whatever reason, design purposes, change it from a 3mm chamfer to a 2mm chamfer. And I can modify those right here at the assembly level without going into the part. And then again, also very similarly, as we saw before, this part doesn't have any actual features, but maybe our design criteria is that maybe we need to add a little bit more strength to the interior, and we want to remove a cutout. So Solid Edge has a nice tool that allows us to recognize features. In this case, I want to recognize the cutout in the part, and I just simply hit delete on my keyboard and remove that from the part. Just by selecting those faces, I can modify the part itself and remove that. So what has this done to the actual part? Well, if I go into the part, what you'll notice that we've done from that assembly level is not only do we not just have a body feature, but now we have intelligent hole features and intelligent chamfers because we've now recognized and placed that intelligence back into the part. And then very similar to what we did earlier, if I wanted to come in and add my own relationships or dimensions to this part, if I want to add dimensions and maybe modify those dimensions, maybe change the thickness of those ears to some other value, you'll notice I can change those, and all four of those ears in this case are going to be modified at the same time because, again, Solid Edge recognizes automatically some of the intelligence in this part. Again, if I wanted to add maybe one other dimension, maybe the spread distance here between those features, again, I can change that also. But the point I want to make is that we can make those changes at the assembly level and add intelligence very, very quickly back into those imported parts. So let's come back up here to the top level assembly. Again, you'll notice those changes were reflected here. So the cutout's missing, and you'll see also that we've got those intelligent features in this part. So let's take this one step further just to show you, again, even more flexibility that Solid Edge allows you when you're making changes to imported geometry inside of Solid Edge. As you'll notice here, we have some interference between this component and our swing arm. So let's measure what the distance is on the swing arm between this mounting component. And you can see that it's 50 millimeters. Well, again, if I don't want to have to go into the individual part to make that change, what I can do right here from the top level assembly is I can add dimensions at this level. So if I want to come in and specify and place a dimension on these components, what I can do is simply go over to the features that I want to place a dimension on. I simply tag those features, and you'll notice that the spread distance between those mounting ears is 40, and that's why we got that interference down here at the bottom. And what I want to do is I want to change that from 40 to 50, and again, I'm doing that right here at the assembly level. So now the spread distance matches that. If I wanted to add some clearance into that, I could do that very easily. Again, I can just simply select any feature or any face on that part. I can get that dimension back. And if I want to add maybe a millimeter clearance on each side, I can go through and add that and change that design right here at the assembly level. Now by doing that, you'll see that I've added a lot more slop here in between these components. So I can do something very similar on these other parts. If I wanted to come in and maybe add a dimension on some of these other components, I can do that very easily as well. I simply just select the faces or the features that I want to place a dimension on, and I can go through and I can add that very quickly to these components and eliminate that slop. So what we'll do is I'll come in and I'll select that edge or that round. And you can see we can get different point locations if we want to get exactly where we want to place those dimensions, or if instead of doing that, and I'll show you another nice little feature, is if we have placed any dimensions on any of the components already, I simply can just select any of those faces or features on that part, and again, any dimension that was placed on that component will automatically appear on the screen for us. So in this example, you'll notice that I may want to go through and maybe lengthen this part even further from 75 maybe to 85, and again, I'm doing this right here at the assembly level and making that change. So if we were going to go through and again check the validity of our mechanism, I can simply go through again as I change the shock and go from minimum stroke down to maximum stroke, and then we might want to go through and check to see if there's any interference at that maximum location. You'll see that now we have no interference. So we've gone through and made changes at different levels, both at the part level individually as well as the subassembly level, and then also up here at the top level. Finally, if we wanted to just finish out our design here, I can simply just tell Solid Edge we want to add some standard components or some fasteners here. I simply select where it's going to start and then where the end of the hole is going to be, and then Solid Edge is going to come up and allow us to place standard components that will fit inside of the size hole that we've selected. So again, it'll allow us to go through our library of standard components here. I can go through and select for example, socket head cap screw, and it'll go through and find different components here. Once you've found the individual components, maybe in this case it's a 7/16 hexagon socket head cap screw, and I can add that. Maybe for the underside, I want to go ahead and place maybe a nut on the back side. So we'll select maybe a hex nut, and we can go through and pick the corresponding component there and add that. And once I hit OK, it'll go ahead and throw that into our assembly for us, and we can complete our design. So hopefully you've seen some benefits as we go through and we make changes very flexibly here inside of Solid Edge. What I'm going to do is I'm going to change gears a little bit. I'm going to open up and just show you some additional tools that we have when we're working with imported geometry. And these are some nice features that we have inside of Solid Edge. We've got a helicopter assembly that I'm going to bring open and just show you some other tools that we have in adding intelligence back into imported components. So as this helicopter assembly is opening, I'll explain the scenario that we're going to go through. And in this case, we're going to, very similar to what we did with the components where we recognized intelligent hole features and recognized intelligent chamfers, what we're going to do in this case is recognize even more geometry and allow us to add even more intelligence into our components. So here we have a helicopter. And we'll go ahead and rotate this around to the back side. And what you're going to notice is we have a cooling fan on the underside of the helicopter. And what I want to do is I want to take, again, these components and make some design changes. So we're going to open up one of these parts, and again, as I go in and show all the documents in this particular component, you'll see that as I open it up, very similar to what we saw with our SolidWorks data, is we just have a dumb solid, is what the industry calls it, where there's no features or no intelligence built in. So what we want to do is, you'll notice that these hubs on the outside, there are 12 of them, and maybe some design changes that we want to make for this particular design process is we want to go from 12 down to 8. Again, how do I do that if I don't have those features or have that intelligence built into this part? And again, this is where the question comes up: do I just redesign this part and build that intelligence in as I'm redesigning it, or is it easier to make those changes here? Well, in Solid Edge, I think it's going to be a lot easier to just make those changes, and I'm going to show you how to do that. So we'll do something similar to what we did earlier. Is the first thing that we might want to do is just recognize the holes in this part. So very much like what we did in the previous example, you can see that Solid Edge will automatically recognize any holes in the part, and we've done this already. So let's just maybe rename some of these holes. We'll call this the center hole. For this hole down here, let's call these the outer holes. And then hole number 3 that it recognizes, we'll just call this the inner holes. And again, just like what we did earlier, if we wanted to go through and change any of those settings, we could. For now, we'll just leave them as the same. But again, you'll notice that Solid Edge is going to add that intelligence back into this model, so that if I wanted to come back in later and change the hole type, I can do that very easily. The next thing is, those holes represent or are displayed as a pattern. So instead of just recognizing the individual holes, let's show you another tool here where I can say, let's recognize hole patterns. So again, I can just select the entire model. The center hole doesn't really represent a pattern, so we'll deselect that one. But again, as I execute that, Solid Edge is recognizing hole patterns as well. So the first one here, this will be the outer hole pattern. And I can come in and specify the same thing for the inner hole pattern. And what's nice about this is, what you'll see as it recognizes those patterns, again, it lists them over here, is it'll automatically parameterize those patterns. So it'll recognize or create automatically for us a dimension on the part, which represents the diameter of those hole patterns. So for example, if I wanted to take the inner hole pattern and change it from 62 to 65 as an example, I can do that just by simply changing that dimension, and you'll see those inner holes shift out just a bit. Or we can take that back to the original value of 62. The other thing that it'll do with those patterns is it'll recognize the number that represents, and we'll see that here in just a few minutes. So we've recognized the holes, we've recognized any patterns here, but what about some of these other features that are displayed? You'll see that we have slots. You can see that we have these hubs here on the outside, and those also look like features that are represented as a pattern. So what's nice about Solid Edge is we have the ability to select geometry, and we have this nice function called Like Me Patterning, and basically what I select, I could tell Solid Edge to look for things like me. And as I select that, it'll find all of the corresponding slots. So again, I'm going to call this our slot pattern, and Solid Edge will recognize that. And then the same thing here for the hub. Let's maybe zoom in here on this bottom hub for a second. I'm going to simply select all of the geometry in that hub. And again, like I did with those slots, I'm going to tell Solid Edge, find anything like me. And again, it finds all of those patterns for the hub, and we'll call this the hub pattern. And again, it's going to place a dimension out there for the diameter, in this particular case, for that as well. So what does this allow us to do? Well, what's nice is as I come into this built-in parameter table for inside of Solid Edge, is let's say our design change is we're gonna go from a 12 hub component to an 8 hub component. Well, even though I didn't have those original features, I can still add that intelligence back into this part. So I'm going to take the hub pattern, I'm going to just copy that to my clipboard. Now these outer holes, there's also 12 of those. I always want the hub number of instances of the hub to match the outer hole count. So I can make those equal to each other. And let's say, for example, I always want the number of slots to be half the value. So I can also put in a formula here where I can say I want that to be half the value. And I'm simply adding even more intelligence into this part. So what I'm going to do is I'm going to turn off the outer hole pattern just for a second, just to show you what this is going to do. So let's just simply turn off the outer hole pattern. And what I'm going to do is I'm going to change the hub pattern count from 12 to 8. And we should see the outer hole pattern adjust to 8, and we should see the slot pattern adjust to 4, which it did. And you can see that graphically as well. So again, we can now link patterns together. And let's go ahead and turn on the outer hole pattern. Let's just go ahead and show that again. And you'll see how Solid Edge adjusted that. Now, as we made that change to the number, you can see that maybe they're not placed or spaced where they should be. So we'll do one more thing here. And again, this is the power of Solid Edge with Synchronous Technology, is I can come in, I can select the slot, and I'll also select that hole. And this nice little tool that you see down here is what we call the Solid Edge steering wheel. It gives us great flexibility in making modifications directly with the model. And what I'm going to do is I'm simply going to point to the center of our hole here, and then I'm just going to adjust all of these slots and all of these holes to a new location. And I can simply use that steering wheel to place those right here at the midpoint and adjust those to make our part look exactly the way that we want it to look. So again, the example here was bringing in this component and adding in even more intelligence with patterning, whether it's a hole pattern or whether it's a pattern of other geometry like these slots or these hubs, and having Solid Edge be able to recognize those so that we can make changes to that downstream. Now finally, in this last example, I don't want to eliminate those companies who have 2D data. So I'm going to come in and we're going to go through and show some other tools as well. And this time we're going to utilize AutoCAD or DWG or DXF formats. I'm going to bring in some of this data as well and show you what we can do with 2D data. But there are going to be scenarios out there where maybe your company has legacy data from any other CAD system. And again, that CAD system can be anything. If you've utilized another 3D CAD system, you probably have existing 3D models. You may have some existing 2D drawings. And I'm going to show you another tool that Solid Edge has that allows you to take both of those file types, essentially marry them together, and make changes again on the fly. So again, in this example, I have a Parasolid file type, and this could be a STEP or an IGES or an Inventor or SolidWorks. It doesn't matter where it came from, but I can open up, again, this neutral file format. This happens to be a sheet metal part. But again, like we've seen throughout the demonstration today, again, there's no intelligence built into this component. It's just what we call in the industry a dumb solid. But what's different about this particular part is I have its corresponding 2D print or 2D drawing. And I'm going to open that up as well. And you'll see here we've got the print, we've got the corresponding dimensions, we've got the border, we've got all the information here. And you'll notice we have full control over layers. So if I have layers and I want to hide specific layers, I can turn those off. But what I want to do is I actually want to utilize this information. It's been created already. I don't want to recreate this. I don't want to manually make changes to the 3D model. I want to take the manufacturing information from the 2D print and have it automatically placed onto our 3D model. And Solid Edge has a nice tool for that called Create 3D. Now what Create 3D allows you to do is if you didn't have a solid model, if you wanted to take the views of the 2D print and quickly create a 3D model from them, you could do that. But I also may want to go through and simply use the 3D model that I have. Before I do that, let me come back to that part. Let me go ahead and save that to disk. And as I come back to the 2D print, as I utilize this Create 3D tool, I can say add this print to the existing file. So I've brought in the 3D model. I'm going to have Solid Edge take the 2D print and simply put it with the 3D model. And all I simply have to do is select the information that I want to bring in. If I want to select the third view, I can. I don't need to necessarily for this particular part. But what you'll see here is that it places the 2D print information relative to the 3D model. What I'm going to do is, again, utilize that same steering wheel tool, and I'm just going to line the print up with the 3D model. And I can do that very easily. I'm moving essentially in space both of those 2D sketches with their dimensions and just plopping them right on top of the 3D model. What's nice about this is I can have the dimensional information jump right from the 2D print right to the 3D model. And just to prove that, I'm going to take those 2D sketches and I'm just going to delete them. I don't need them anymore because now that 2D dimensional information is now automatically attached to the 3D print. And again, just like what we saw before, if I want to make changes to this sheet metal part, I can come in and if I want to change the gap or the spacing between those components, again, I can utilize the dimensions to do that and make those changes automatically. Now, before I move further, that's nice. That's a great way to bring that information across. I can make those changes automatically, but I still have kind of this what we call dumb part model per se. I don't have any specific features. And with this being a sheet metal part, I may need a flat pattern. So what's nice again about Solid Edge is I have the ability to take this dumb solid and say convert it to a sheet metal part. And now what you'll notice is as soon as I do that, now it creates intelligent tabs and flanges that I can now go through and manipulate with specific parameters. If I wanted to change things like bend radiuses or things like that, I can now manipulate those individually. And then that also gives me the ability to come in and generate a flat pattern. And that flat pattern will give us a nice overall sheet size. It tells me exactly what the width and the length of this sheet needs to be in order to create this part. But now I can go back and forth between a nice parameterized formed sheet metal part that has all the manufacturing dimensions as well as the flat pattern for the manufacturing of this sheet metal part. So hopefully today we showed you many different ways that you can bring in many different types of geometry from any type of CAD system, add in that intelligence, and hopefully we showed you how flexible you can be, whether you're working with your native Solid Edge files or you're bringing in data from other sources, and how easy it is to work with this data, make changes to it, and not have to start over from scratch. With that, I'm going to turn the session back over to Dan for a wrap-up, and we'll open it up for the Q&A session.
Very good. Thank you, Kevin.
Okay, now Dan we should be able to see Dan's screen. Let me see. Dan, are you okay? You should be able to share your screen now. Fantastic.
Okay, great. Well, thank you, Barbara. Thank you, Kevin. So in conclusion, just want to wrap up. Today's key takeaway, I think, is hopefully we've demonstrated or proven to you that there is a difference between traditional CAD and their limited ways of modifying imported geometry. and what we call today next generation CAD, Solid Edge's synchronous technology and the flexibility to make changes to those imported geometry. You might not even say we import the geometry at all. We simply open it. It doesn't matter to us where it was created. We open it. And Kevin showed you how to make changes to that foreign geometry once it's inside, easily, directly. So it's a flexible system. So I think the key takeaway is if you do a lot of this work on a daily basis, weekly basis, a lot of importing of other people's CAD geometry, you might want to take a look at Solid Edge and see if it can make life a little bit easier for you. Solid Edge is the solution that we're showing today. It is, we showed you the assembly modeling, CAD, the CAD modeling, the sheet metal design. There are some other applications. I won't go through all of these, but it is a full portfolio of Solid Edge applications. With that, we'd like to open it up to questions, any questions that you might have. Barbara, do you have any questions?
No, I think everybody was speechless, to be honest.
Okay.
I think, yeah, I think Kevin was so professional. What a great webinar. I think everybody agrees, and I think I would like to urge everybody to spread the word, because this webinar, it's recorded, so will be posted on YouTube channel of Novedge, and go back, tell your friends, share it. It's a great one.
Excellent.
So
yes. I'll just move on just one more slide, and if anybody wants to learn more, I want to let them know that they can try Solid Edge for free. We do have a 45-day free trial program. Or if you're just looking for more information about Solid Edge, you can, of course, call Novedge. The information is there on the screen. So I'd just like to say thank you to Novedge again, to Barbara and Kevin, and I'll turn it back to Barbara now.
Thank you. I would like to thank you both. This was really flawless, incredible webinar. Loving the flexibility and the speed. That is fantastic. I want to thank everybody for attending and participating. And I would like also to remind everyone to visit our page at novedge.com, where you can take advantage of the special buy one and get one Solid Edge promotion. This promotion ends on September 23rd, and this kind of promotion don't come often. So I believe this is the 20th anniversary of Siemens, so it will be a while till you get another one. So I urge everybody to come and get it. Also, for information on our latest specials and new releases, join the Novedge Network on Facebook, Google+, or Twitter. And don't forget, the next webinar is a look at Arcon-Evo, next generation architectural visualization software from Elecosoft. And remember, this webinar has been recorded, so you can go back at any time. Just check our Novedge, Vimeo, or YouTube channel. And I thank you, Dan and Kevin, for a flawless presentation. And follow us on our next webinar series. And have a great day, everyone. Bye, Dan, and bye, Kevin. Thanks again. Bye.
Thank you. Goodbye.
Thank you.